Hi there, welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be learning about thermal insulators. This is part of the GCSE physics course, but is also a required practical. So if you want to find out more about it, please feel free to stick around. Share, like, comment, and subscribe for all different GCSE videos in terms of biology, chemistry, and physics. And you can also find me on TikTok and Instagram at the GCSE science teacher for more help. So the question of the day is, how are seals similar to coffee cups? I know we've been asking this question. We want to know the answer for so long, and today is the day that you finally find out the answer. So seals are similar to coffee cups because they both have materials which act as insulators. An insulator, by definition, is a material that prevents or reduces the rate at which thermal energy is transferred to the environment. And seals have special tissues called blubber, which actually prevent how quickly thermal energy is transferred. So the seal can live in very cold environments without being too cold so that it cannot function anymore. So its core body temperature is maintained. Coffee cups are similar because they are made of other materials like polystyrene, which actually act as insulators to maintain the hot coffee temperature. So, as we walk around and do our everyday activity, our coffee or hot drink can stay warmer for longer. And you can see this in all different examples, such as housing and clothing, all of which act as insulators to keep the temperature maintained. Now, at GCSE, you need to know about this practical, and the aim of it is to compare the effectiveness of different materials as thermal insulators. And your teacher might give you different materials to use. You may be able to choose them and design your own experiment, but they're all kind of going to be the same in terms of the apparatus or the equipment that you need. So you need a stopwatch to measure the time. You also need a thermometer to, of course, measure the temperature. You're going to need a large beaker and a smaller beaker that will fit inside the bigger one. So I've gone for a 250 ml beaker and a 50 ml beaker. You also need a lid to cover these beakers. So I've gone for cardboard that I can cut a small circular hole into for the thermometer to fit through. You're going to need some water and a kettle to boil that water. And of course, the different insulating materials you are going to investigate. So in this case, I've gone for some paper, some foil, some cotton wool, and you can also just look at air as well if you want to and how well that works. Fun fact, insulating double glazing, so the windows in houses use air to contain some of that and insulate some of the heat in the house, so it makes it more efficient, which is pretty cool. You also may want to look at how no insulation affects temperature, and then you can compare your results. That would also be very useful to do as well. So, the method then, you are going to place the smaller beaker into the larger one and fill the beaker that is inside with a certain amount of water. You could say, if you've got a 50 ml beaker, say 25 mils of water inside there. That way, it's halfway full. You want to make sure that the amount of water you use, the volume, is the same every time you do the experiment. That way, you can maintain a control variable. So, a control variable is something you keep the same so that you can compare your results in the future when you look at your analysis. You want to then put your cardboard lid over the top of your beaker with the hole in so you can place your thermometer through, and you want to measure the initial temperature. Because it's been boiled, it's going to be very likely to be 100 degrees Celsius, but measure it anyway, check what it is because there may be some discrepancies. You want to record this into a table, by the way, as well, and start the stopwatch, because what you're going to do is measure the temperature every 2 minutes for a total of 20. Now, this time can differ depending on how much time you have and how much time you want to spend on each type of insulating material. Because what you need to do is repeat this a few times to calculate the mean average, but also repeat this for the different materials you are using. So, some ways I've done this as a teacher in the past, I've asked some members of the class to investigate cotton wool, some to investigate the effectiveness of foil and paper. And then we just share our results as a class and compare them that way. However, if you have lots of time and you want to spread this across lots of lessons, by all means, you can do it however way you like, and your teacher might decide to do it in a different way, and that's cool as well. Let me know if you have done this in a different way. I'd be more than interested to know. But once you get your results, you want to plot it on a graph, and that way you can look at the different bits of data and analyze them. But if we want to look at the apparatus setup, it looks something like this. One of the things I've noticed students often do, if you have your thermometer inside, and it's covered, the bigger beaker has the insulating material. You can see in this case, I've got some cotton wool that's covering the smaller beaker, and the bigger beaker around it. Some students will often find it really difficult to read the thermometer, so they lift the lid up and check. That way, you're going to actually release lots of thermal energy into the environment, and that is going to affect your results. So that's something you can write in your evaluation. But also, I often get my students to place a thermometer really close to the edge, so that way you can actually see the temperature changing without lifting the lid, and that helps us get much more reliable, accurate results too. Also, health and safety for anyone who is doing this, please be very careful. You're using goggles at all times because you're using boiling water. You want to stand up when you do this experiment. If anyone does accidentally burn themselves using running the scald under a cold water for 10 minutes and seeking medical attention is obviously the best thing to do in this case. And if you do spill anything, obviously clear it appropriately so no one slips and things like that. But obviously, your teacher will run through this, but these are just some safety precautions to be aware of too. When you do get your results, though, you should be able to plot it on a graph. This is a very crude drawing of a graph, I will say. I am more than happy to do a whole video about graph drawing. I've seen dare I say, a trend in graph drawing over the time that I've been a teacher. Lots of students either find it really great and enjoy it. Some students really struggle and don't like it at all. I'm more than happy to share my tips and tricks with graphs if that's something you're interested in. Let me know below in the comments, and I'm more than happy to help. But you obviously want to make sure you have you're using pencil, you're writing your um, axis labels. So temperature in degrees Celsius is on the Y, time is on the X in this case. And because, like I said, we were looking at the temperature over time in minutes, I've put it in minutes. You can put it in seconds if you want to. I have three different lines here. So A, B, and C, that just indicates the three different insulating materials. To improve this graph, I would definitely have a key to identify which is which. But it doesn't really matter at this point. The point is for me to show you this. The shallower the graph, or the smaller the gradient, the slower the rate of energy transfer, and that tells you that the insulating material is working much better. Okay, so in this case, A is the best insulator because it has a shallower or a smaller gradient. It says here the curve which takes the longest time for the water temperature to drop should be the material which is the best insulator. And it is in this case. You can see that A has a higher temperature than B and C after all of them start at 100 degrees Celsius. That tells you that it's working at the best capacity that it can compared to the others. I hope you did find that video helpful. If you did, feel free to like, comment, and subscribe. Share your thoughts in the comments. It's always good to hear from you. You can also find out more GCSE content for physics, biology, and chemistry on my Instagram and TikTok at the GCSE Science Teacher as well. I have been the GCSE Science Teacher, and you have been curious. So thank you so much for your time. Have a great day, and I'll catch you in the next one. Bye.